All right, this is Mr. Morgan's physics class at Springville High School, and we are excited to give this answer to the Trebuchet Challenge.
Woo!
All right, here is Sydney and Cole.
Alright, so since they both are released at this height and they both end up hitting the wall at the same height, they're both going to end up with the same velocity because everything that this second projectile gains right here, it's going to just lose right back here again. So they're going to end up with the same velocity.
Great, that's conservation of energy. Let's look at the next part.
Okay. So first thing we did was we decided to split up the question into 3 parts to make the answer more manageable. We answered how much energy did the counterweight lose, what the final kinetic energy was, and through that we were able to find the final velocity. So to find the initial potential energy of the counterweight, we just used the potential energy formula U equals mgh, and we solved for the energy, which was 294,000 joules.
And using this initial kinetic energy, we can find the final kinetic energy. So the initial energy is 294,000 joules. Using U equals mgh, we can find the potential energy that it would have at this point on the wall, which is 90 times 9.8 times 15, or 13,230 joules. So using the initial kinetic energy minus the gravitational potential that you would have at that point, you get the final kinetic energy, which is 280,770 joule.
Through having the final kinetic energy, we were able to use the kinetic energy formula to solve for the final velocity, which is 78.98 meters per second.
Excellent work. Let's give them a round of applause. Thank you, Kaylee and Rebecca.